In this lesson, we are going to look at how to graph rational functions. Now, rational functions are those weird things that maybe your teacher's been showing you in class and it looks something like this. So maybe you saw your teacher doing something super weird, like you've got these asymptotes. Like, what are asymptotes? And, okay, maybe not like that, but maybe at y equals to 0, there's a dotted line, and then, I don't know, maybe the graph went like this, and like this, and like that, for example, and you were sitting in class and you were like, okay, like, life just got real. So in this lesson, I'm going to show you exactly how to do these types of functions. It's not actually that bad. There's a set of steps we need to follow, and by the end of this lesson, you should be feeling more comfortable. So let's go for it. Let's have a look. So here's our first example. Now, what I want you to do is, well, we've got categories that we're going to do. But before we start any of this, the rule is we actually want to start by factorizing. Factorize. Okay? So factorize the top and the bottom as much as you can. So at the top, we cannot do anything. At the bottom, you could take out an x as a common factor. And so we're going to end up with f of x is now going to be equal to 1 over x, and then in bracket, x plus 3. Okay, so we factorized it. Now, if there was something at the top that was exactly the same as something at the bottom, then we would have cancelled that out, and that would have been called a whole. But in this example, there is nothing that is the same at the top and the bottom, so for this example, there is no wholes. There will be some wholes in the next example that we're going to do after this one. Well, one of them, I know I did include one of them for this video, but not for this example. There's no wholes. Okay, asymptotes. Asymptotes are the dotted lines. There are 3 types of asymptotes that we need to deal with. Vertical, which, as the name suggests, they are vertical. Horizontal, yep, you guessed it, they are horizontal. And then slanted. Yeah, that's right. They also go in the same as the name suggests, so they are slanted. Okay, so for you to be able to find vertical asymptotes, make the denominator equal to 0. Okay, so we take the denominator, which is the bottom part, and we make that equal to 0. And what do we get? Well, you would get x is equal to 0, and you would also get x is equal to negative 3. Those are going to be your vertical asymptotes. So at x equals to negative 3, draw a vertical line. At x equals to 0, draw a vertical line. So I'm just going to do it like that so we can make sure we remember there's a line there. Okay, that's your vertical asymptotes complete. To find horizontal, well, that's a little more interesting. We need to take a look at that. So let's quickly go talk about that. With horizontal asymptotes, all that I want you to do is always think about the numerator at the top, the denominator at the bottom, and there are 3 different categories that we need to learn about. Category 1, let's actually make it more neat. Let's say category 1, this is when the denominator is bigger than the numerator. I'll explain now. And then number 2, let's say the denominator and the numerator have the same what, Kevin? Don't worry, I'm going to explain it now. And then in this one, the numerator is larger than the denominator. Okay, so what am I talking about? So, you know how they give you an equation? So for example, let's say we had x3 plus 4x squared plus 2x over 7x to the power of 5 plus 3x plus 1. So what I want you to do is look at the largest exponent in the numerator. Then look at the largest exponent in the denominator. It is those 2 numbers that I am talking about when I'm talking about these things over here. So if the denominator number, which is the 5, is larger than the numerator number, then we are in this category. Then what you do is your horizontal asymptote will go like this. It will be y equals to 0. That will always be the case. Okay? Now, what if you have a situation like 3x squared plus 2x divided by x squared plus 4? So look at the largest exponent in the numerator. Look at the largest exponent in the denominator. They are equal to each other. If this happens, then the answer will be y equals, and then what I want you to do is take the numbers in the front of this x squared. Okay, so take the numbers in the front of the x squared. So it's a 3 And then at the bottom there is a 1. So that would be y equals to 3. Done. Then in the last category, we'll have something like 3x to the power of 6 plus 2x squared plus x. And then at the bottom, you might have 2x to the 3 plus 4x plus 1. If we look at the largest exponent in the numerator and the largest exponent in the denominator, we can see that the numerator is larger. When this happens, then there will be no horizontal asymptote. Okay, there won't be one. So those are the 3 scenarios that you need to be aware of. So if we come back to this one, we can see that at the top there is nothing there. So you could think of that as x to the 0. So the numerator has a 0, the denominator has a 2. So the denominator is larger. So if we look at that, that would be this category over here. So the answer will be y equals to 0. That is your horizontal asymptote. So you can say y is equal to 0. So what does that look like? Well, y equals to 0 is a horizontal line because it is a horizontal asymptote, but it's on the x-axis because it's y equals to 0. Now we need to talk about slanted asymptotes. So there is a specific thing you need to look out for. So once again, you can look at the numerator and the denominator exponent. There will only be a slanted asymptote when the numerator is 1 more than the denominator. So for example, if you have x to the power of 3 plus 2x squared divided by x squared plus 6x plus 1, for example, then look at the numerator denominator. The largest one is a 3. In the denominator, it's a 2. So for this scenario, when the numerator is 1 more than the denominator, there will be a slanted asymptote. Smiley face. If there is any other scenario, then there will not be a slanted asymptote. For example, if you have x squared plus 3x plus 1 over x to the squared plus 2x plus 5, for example, can you see that these are the same? No slanted asymptote. What about 3x to the 4 plus 2x squared over 7x to the power of 7 plus 1x to the power of 5? Look at the denominator, the numerator, it's a 4, the denominator, it's a 7, no slanted asymptote. There will only be a slanted asymptote when the numerator is exactly 1 more than the denominator. Okay? So if we look at this example, the numerator has a 0, here it's a 2, so you are not going to get a slanted asymptote. No. Okay? So there we go, we've done all the asymptotes. Vertical, how did we do that? You made the denominator equal to 0. Horizontal, I showed you the 3 different categories. Slanted, I showed you how that works. Now we need to look at intercepts. You know, x-intercept and y-intercept. So to find an x-intercept, you just make y equal to 0. So you take your equation and you make y 0. So what I like to do is I take this to the left by cross multiplying, and you end up with 0 equals to 1. That's pretty awkward because that doesn't exist. So that means there's no solution here. What that means is that there is no x-intercept. So that means that this graph never ever ever cuts the x-intercept, which is pretty interesting. Okay, now to find a y-intercept, you make x equal to 0. Okay, so we go and we make x equal to 0. Ooh, okay, so we're going to end up with y equals to 1 over 0. Try type in the calculator, it's going to give you an error. So there's no y-intercept either. Okay, this is a weird graph. Okay, but that's fine. None of this is incorrect, it's all okay. So now, we are almost done. So what I want you to do now is I want you to look for all of the vertical asymptotes. So where are the vertical asymptotes? Here's the one. Okay, I don't know why that was so skew. And here's the other one. Okay, and what I want you to do is I want you to see what happens to the graph. So what happens is that graphs always they act really weird when they get to vertical asymptotes. Okay, they cannot ever cross them, so they do weird stuff. They go like really close. They do something like that, or maybe they go downwards. Okay, they can either go up or down along the vertical asymptote. The same is true for this one. It could either go up, or it's going to go down. And we got to try to figure out, oh, sorry, it could have gone down on that side. And then on this side, you got to check out if it's going to go up or if it's going to go down. So we got to sort of try to figure out what's going to happen at these vertical asymptotes. So the way that you do that is you take the factorized form, which we had earlier, so just makes it better to work with. Now, listen carefully. You're going to choose an x value that is very close on this side. So you're going to have to choose a point here, then on this side, then you're going to have to check on this side, and then you're going to have to check on this side. So you're checking on either side of the vertical asymptote. So for this one, I would say let's use x as minus 4. So if you had to put x as minus 4 over here, then you don't even have to fill it in, but you can imagine that this would be a negative number, right? I know it's negative 4, but it'll be a negative. And then if you had to put negative 4 into that x value, what would happen to that bracket? Well, it would be negative 4 plus 3, which is a negative number. So if you had 1 over a negative times a negative, now a negative times a negative would become a positive, and 1 divided by a positive is still going to be a positive. So over here, the graph is positive, meaning it's going upwards. What I mean is that if it was negative, the graph would be down here, so it would be going that way. But we know that it is positive, so it's somewhere over here, so the graph is going up like that. And so what happens is that it would go along the horizontal one like that. Okay? Now what we need to do is check what's happening on this side of the vertical asymptote. So I'm going to plug in negative 2. So if you had to plug a negative 2 into that x value, it would be negative. If you had to put a negative 2 into this bracket, it would be a positive. So if you had a negative multiplied by a positive, you would get a negative. And then if you say 1 divided by a negative number, you're going to end up with a negative number. Okay, so that means that on this x value, the graph is in the negative part, so it's going down like that. It can't be going up like that, because then the y values are positive, but we just saw that they are negative. Okay, so we're going to do that. Now we need to see what's happening on closer to this side. So I'm going to choose this x value here, which is negative 1. So if I had to put negative 1 over there, that would be a negative number. If I had to put negative 1 into this bracket, it would be positive. And so if you had a negative multiplied by a positive at the bottom, you'd get a negative, and 1 divided by a negative is overall just going to give you a negative. So you see how I don't actually plug the value in? It just takes a bit longer. You can if you want, but it's not necessary. So the graph's negative, so it's somewhere around here, so it means that it's going to go down. It can only go up or down along the vertical asymptote. So if it's in the negative part here, then it must be going down. Okay, so what would happen then is it probably goes up like this and then doesn't cross this horizontal asymptote and then turns around like that. And then we just need to see what's happening on this side over here. Sometimes it does. It can cross the horizontal asymptote, by the way. I have got examples like that, but that would have only been if we had something like this. Let's say this answer was positive, so it was going up. Then the graph would have done something like that. Okay? It can cross the horizontal asymptote. It can also cross slanted asymptotes, but it can never cross vertical asymptotes. Okay, but I'll talk about that a bit more as we go along. Now, we need to quickly see what's happening over here. Either the graph is going up or it's going down. So we will need to choose an x value to the right of this one. So I'm going to choose x equals to 1. So you can go plug x equals to 1 in if you want, but I just do it like this. That's why I call it sign analysis. So for this, if I put a 1 there, that's a positive number. If I put a 1 into this bracket, that's also going to be positive. And so you're just going to end up saying 1 divided by a positive, because a positive times a positive is a positive. And so everything's just going to be positive. Okay? And so that's going to go up. And so this graph is going to look something like that. Here's our next example. So what we're going to do first, remember step 1, factorize. So factorize the top, factorize the bottom. So at the top, it's just a normal trinomial. So that's going to give us x minus 3, x add 2. Then at the bottom, take out a common factor of 2 and you'd be left with x squared take away 4. But now x squared take away 4 is a difference of squares. And so that's going to factorize as x take away 2, x add 2. Now, here's where we can start talking about wholes. So you see how these two are exactly the same? So what you're going to do is you're going to cancel them out. Okay. Now they are going to be a whole. So what you're going to do is you're going to say x add 2, make it equal to 0, just to see where the whole is. So the whole is going to be at -2. So somewhere along this -2, there's going to be a whole. Now what's really weird is normally, if you wanted to find the y value, you would just go plug it in, right? But what's weird about holes is when you want to find the y value of that hole, you go plug it into this part over here, and you don't plug it into that part over there. And so you would end up with -2 take away 3 over 2 times -2 take away 2. And so you end up with -5 over 2 multiplied by -4. And so you end up with -5 over -8, which is 5/8. So if we had to go plot that quickly, so when x is -2 and y is 5/8, 5/8 is like 0,625. So -2 and then 0,6 would be like there. Okay, so that's going to be a whole. It's literally a whole like that. Okay, so we've got the whole. Fantastic. So just remember, factorize, and then if there's any part that cancels out, that part is the whole. Then to find the y value of the whole, ignore that part and then plug the x into the leftover part. Now for the remainder of the question, you can actually just ignore those parts completely. Okay, so for the asymptotes, we've got vertical. Let's rather just say V for vertical, H for horizontal, and S for slanted. Now remember, I showed you each of those. So for vertical, make the denominator 0. So, but now you don't have to worry about this part. Remember, that part's technically, you can ignore that. So you're only going to look at that part over there. So you're going to say 2 times x take away 2 equals to 0. So you can do this however you want, but you should end up with x is equal to 2. Okay, so you're not going to include the whole part as your the part that was a whole in your vertical asymptote. So we're just going to have one asymptote at x equals to 2. There we go. Your horizontal asymptote, remember this is where I showed you the 3 different categories, where your numerator and your denominator. So here the numerator and the denominator have the same exponents. Now I know, yeah, you don't want to come down here when you're looking at the numerator denominator. You want to look at this original expression. So it's the same. So remember, when they are the same, then your horizontal asymptote is going to be y equals, and then you're going to look at the ratio of the numbers in front of the x squared. So there's a 1 over there and a 2 over there. So it's 1 over 2. So y equals to 1 over 2 is a horizontal asymptote. So we're going to put that in over here. Wait, so that's 0.6. Yeah, so your horizontal asymptote would be exactly in the middle. It's a little bit lower than 0.6, so it's there. Okay, and you can say y equals to a half, and here we should have said x equals to 2. Then vertical asymptote has been done, horizontal asymptote has been done. Slanted asymptote, there is not going to be one, because remember, a slanted asymptote would only have one of those if this exponent is exactly 1 more than this exponent. So there's no slanted. Okay, so all of the asymptotes are complete. Intercepts. Okay, so to find the x-intercept, make y 0. So let's say to find x-intercept, make y 0. So if y 0, okay, so what I do is I take this and I try to multiply it over, so it just becomes 0. So you're actually just making your numerator equal to 0. So this is your numerator, and we're making it equal to 0. We already factorized this earlier. And so if you had to solve, x would be 3, or x would be equal to -2. But we're not going to use the x equals to -2 because that is a whole. So we can't use the whole. So we're going to say x equals to 3, which is over here, and so that's going to be our x-intercept. To find the y-intercept, we make x equal to 0. So you can make all of these x's equal to 0. So you're going to get 0 squared, take away 0, take away 6, over 2 times 0, take away 8. And so you're actually just going to be left with 6 over 8, which simplifies to 3 over 4, which is approximately 0.75. So that's about there. Now we just need to use sign analysis to see what happens along the vertical asymptote. Remember I showed you in the previous example that, I mean, this one's going to be pretty easy to see, to be honest. It's either going to go up or it's going to go down. Okay, it cannot go down because I can see that the graph already has a y-intercept, which is above this line. Okay, so the graph is going to have to go, wait, where was that? So the graph is going to have to go up. If you say, yeah, but it's going to go down, it cannot go down because then it wouldn't go through that point. You see, it would do that, and then it wouldn't go through that point, so that wouldn't make sense. So this graph is going to go, okay, now it goes through the hole, and then carries on like that. And then over here, it could either go like this, or it could go like that. Now, I know that it's going to be the one at the bottom, because it has to go through this point, because that is the x-intercept. So it's going to do that. And there we have it. Here's our next example. So step 1, factorize. So we're going to factorize the top. You could take out an x, and then you'd be left with x squared, take away x, take away 12. And then at the bottom, you can take out a 4x, and you'd be left with x plus 1. Now we can still factorize that trinomial as x take away 4, x add 3. You may just want to pause and make sure you agree with me on that. And then 4x, and then x add 1. Okay, so there we factorized. Now, is anything at the top the same as... Ooh, actually, check this out. This x and this x is the same. Don't worry about the 4, that doesn't matter. But that's actually the same. So because they are the same, what's that going to be? Well done, if you remember, that's a hole. A hole is going to be at that part there. So to find out exactly where the hole is, you make that part equal to 0. Well, that's just going to be x equals to 0, of course. Now, we need to know the y value that goes with that x value. Now, don't go take this x value and plug it into this equation. You have to. It's quite weird. You have to plug it into this equation after the x has been cancelled out, after the hole has been taken away. So go plug it into that. So 0 take away 4, 0 add 3, 4, and then 0 add 1. And if you work that out, you end up with negative 3. So if x is 0, y is negative 3. So that's going to be our hole over there. Okay, so there's the hole. Nice. Right, now for the asymptotes, remember there are 3 types: vertical, horizontal, slanted. For vertical, you make the denominator equal to 0. So you make the 4x squared plus 4x equal to 0. And we already factorized this earlier, and you end up with that. But ignore the hole. So don't do the whole part. Okay, I mean, you can go solve this. You would end up with x equals to 0. Or x equals to negative 1. So this part's a hole, so you don't want to put that as your asymptote. But x equals to negative 1, that's going to be a vertical asymptote. So you can go draw that in with a vertical line, because it's the vertical asymptote. There we go. For the horizontal asymptote, that's where you need to think about the 3 different categories which I showed you. Remember over here? So in this scenario, in our question, we have a numerator exponent that is exactly 1 larger than the denominator. So that is going to be a slanted asymptote. Or first, let me show you that when the numerator is larger than the denominator, there is no horizontal asymptote. Okay, so we'll talk about the slanted one now, but there's no horizontal. Okay, so I was getting a little bit ahead of myself. So there's not going to be a horizontal. So the slanted, there is actually going to be a slanted, because our numerator is exactly 1 more than our denominator. So there will be a slanted asymptote. So let me show you how to do this. Alright, so to work it out, you're actually going to have to go and use division. Yeah, I know, not the greatest, but we have to do that for slanted asymptotes. So you're going to go do division. So you're going to say x cubed, take away x squared, take away 12x, and you're going to divide that by 4x squared plus 4x. Now, I assume that you've watched, or you know how to do division, but in summary, you're going to take the largest exponent here and the largest exponent here, and you're going to divide them. So you're going to say x3 divided by 4x squared, and that's actually going to give us x over 4. So that's a quarter x. So you can say a quarter x. Now what you do is you take this and you multiply it with both of these. And if you had to do that, you would end up with x cubed plus x squared. Then we need to subtract the top minus the bottom. So I'm going to turn these into, or x cube, so yeah, we're going to minus. I'll show this in different ways, but I think for this one, so x3 minus x3, that's going to give us 0. So those are going to cancel. Then negative x squared minus x squared is going to become negative 2x squared. And then you just bring the negative 12x down. Then you start the process all over again. So you find the largest exponent here and the largest exponent here. And you make the inner one divided by the outer one. Inner divided by outer. So that's going to be negative 2x squared divided by 4x squared. And so that's going to give us a negative 1 over 2. Because this cancels once, this cancels twice, and then you're just left with a negative. So it's going to be negative a half. Then you take that negative a half and you multiply it over here. And so that's going to give us negative 2x squared, negative 2x, and then you're going to minus. So you're going to take this part, subtract this part. And so that's going to cancel out the x squares, and then you're going to have negative 12x take away negative 2x. So it's going to become negative 12x plus 2x, right? Because a negative and a negative becomes a plus. And so it's going to become negative 12 plus 2, which is negative 10x. But we don't even need to know this part, because now the division is complete, because we cannot carry on, because this exponent is now larger than this exponent, so the process is finished. So where is the slanted asymptote? It's this part over here, so it's going to be y equals to a quarter x minus a half, which is a straight line. It's a diagonal line that's going to go somewhere like there, but we need to know exactly where it goes, so you need to remember how to draw straight lines. So I'll remind you. So you start with your y-intercept, which is negative a half. So let's go put a little dot at negative a half, which is over there. And then you use your slope, which is your rise over your run. So your rise is 1, so you're going to rise by 1. And then you're going to go 4 to the right. 1, 2, 3, 4. And you can put a little dot there. And then you're going to connect these with a dotted line, because it's an asymptote. And then you just go right through. Okay, I'm going to need some more points. So what I'm going to do is I'm going to go down 1 and then 4 to the left. 1, 2, 3, 4. And then I'm going to go down 1 again and then 4 to the left. 1, 2, 3, 4. Just to give myself more dots so I can get this right. And then let's do this one. Up 1 and then 4 to the right. 1, 2, 3, 4. So there's our slanted asymptote. So all the asymptotes have now been completed. So now we need to do intercepts. So that's x-intercept, where you make y0. And then we're also going to do the y-intercept. And that, of course, is where you make x0. So with your x-intercept, you make a y0. So that's going to be 0 is equal to x cubed, take away x squared, take away 12x, over 4x squared, add 4x. And so what ends up happening is we take this and we multiply it over to the left hand side, and we end up with 0. And so we actually just end up with our numerator equal to 0. That's actually what we're doing here. So we already factorized this numerator earlier as x, and then we had x take away 4 and x add 3. And so if we then had to go solve this, but we must also remember the whole. So if you had to go solve this, you'd get x equals to 0, and then x equals to 4, and x equals to negative 3. But remember that the 0 is a whole. So we're not going to use that one as our x-intercept, so we'll take that one away. So there we have it. X equals to 4. Let's go put a little dot. And x equals to negative 3. X equals to negative 3. There you are. So there's our two x-intercepts. Fantastic. To find the y-intercept, you make x0. So you're going to put a 0 in all the x's, so it's going to become y equals to 0. Take away 0 squared, take away 12 times 0, over 4 times 0, take plus 4 times 0. Now the problem is at the bottom, we're going to have a 0. And so when you have a 0 at the bottom, that's undefined. So it's almost like it doesn't exist. There's no solution. So there's no y-intercept. So then we're pretty much ready to solve. We could go do sign analysis, but this one's pretty easy. We know that it just has to go through there, and it has to go through there. So this graph is going to go like that. And then it has to go through this point. So the only way it could do that would be like that. Let's do one more. So if you've made it this far, I know you're probably tired, but let's just do one more. So step one, see if you can remind yourself how this all works. So we need to factorize first, okay? So at the top you can't do anything, so we'll leave that as x. At the bottom we could take out a 2x as a common factor, and you'd be left with x squared, take away 2x, take away 3. Now that could be factorized further as a trinomial, so that would become x take away 3 and x add 1. You may need to pause and just make sure that you agree with me there. Now, is there anything at the top and the bottom that's the same? Well, yes, it's this x and this x. So those are wholes. So we know that x equals to 0 is the whole. Now, we need to find the y value. Now, you don't just plug the 0 into here. You plug the 0 into the equation after you've taken those x's and you've removed them. So what we actually have left is 1, because there's nothing else. And then at the bottom you have x take away 3 and x add 1. So you're going to put a 0 in to the place of x. And if you had to go work this out, you end up with negative 1 over 6. Okay, so 0 and negative 1 over 6. Now 1 over 6 is approximately 0.17. So we're going to go to 0 and then negative 0.17, which is like there, and we're going to make a whole. Perfect. Now we need to do our asymptotes. Here's a random little story. It's a Friday afternoon right now, and I'm busy recording, and I've got some people coming over a bit later, and we're going to have, I think in America, I don't know, what do we call it, a barbecue? But here we are, I'm in South Africa right now. We call it a braai. It's like a weird South African word, but we're going to have one of those later. But yeah, so they coming over. But the point of my story was, I'm busy recording right now, obviously, and I've got my dog. He's a husky mixed with a German shepherd, so they call him a Malamute. He's beautiful. And he's busy sleeping here in the room while I'm recording, and I can hear him snoring softly in the background. You wouldn't hear it because I cancel out all the noises in the background, but it's just I don't know, for me it's so peaceful, just listening to that. I don't know, that was just my random little story. I find it very sweet, very comforting, very calming, very relaxing to be able to have your dog with you while you're recording. It's really nice. Okay, so moving on. So asymptotes, we know that there are 3 types: vertical, horizontal, and slanted. Okay, so for the vertical, we said we make the denominator 0. So make the denominator 0. But we already factorized this one, so let me just quickly save us some time. And then we said, and so we're going to make that denominator 0. So you would end up with x equals to 0, x equals to 3, and x equals to negative 1. But remember that x equals to 0 is a whole, so we're not going to use that as part of our vertical. So it's going to be x equals to 3. We can make a vertical asymptote over there. And then, by the way, my dog's name is Harvey. And then we have another dog, a pug. She's called Ella, but she's so cute because she's way smaller than Harvey. I mean, Harvey's pretty big, but she completely controls him. In winter, when it's really cold here, while he's lying on the floor, she'll actually sit on him and like fall asleep like that. And he's completely fine with it. Really cute. But yeah, so there we have our asymptote at x equals to 3, and then also at x equals to negative 1. So let's just go put that in there. Okay, so there's our vertical asymptotes. Now the horizontal asymptotes, this is where you have to think about the 3 different categories. Remember this page where you look at the denominator and the numerator? Yes, that's for horizontal asymptotes. So if we look here, we can see that the numerator asymptote is asymptote. Come on, Kevin. The numerator exponent is a 1. The denominator is a 3. So the denominator is bigger than the numerator. So that means that the horizontal asymptote will be y is equal to 0. So we can go plot that. So y equals to 0 is a horizontal line. So I'm just going to do it like that so we can just remember that there is a line there. And then just say y equals to 0. And then for the slanted, there is not going to be one because this numerator, come on, this exponent would have to be 1 larger than this one, but that's not the case. So there is no slanted asymptote. Okay, so we've got all of that. Now we need to get some intercepts, x and y. So to find an x-intercept, you make y 0. To find a y-intercept, you make x 0. Okay, so we make y equal to 0, and so 0 will be equal to x over 2x cubed, take away 4x squared, take away 6x. But once again, we're going to multiply this up to the top. We're going to get 0 is equal to x. So that's your x-intercept. But that is a whole, so we cannot put that as an x-intercept. It's a whole. Okay, so there's no x-intercept. To find a y-intercept, you make x 0. So you're going to get, so I'm plugging it into here. You're going to get 0 at the top. And then 2 times 0 cubed, take away 4 times 0 squared, take away 6 times 0. And so you're going to end up with 0 over 0. You're not allowed to have a 0 at the bottom, and so there's no y-intercept. Okay, so the last thing that we need to do now is we need to do a sign analysis to try to figure out what the graph's going to do on either side of this vertical asymptote. Okay, and then we need to see what's going to happen on either side of this vertical asymptote, because there's only really two things that could happen. So let's say, for example, on this side, the graph could either go up or it's going to go down, and then on the other side it could either go up or it's going to go down, and then over here it could either go up and it could go down, and then on the last part it could either go up over here or it could go down. And we just need to go figure that all out by just using a sign analysis. So for example, well, first of all, we want to make sure we're using the most factorized form possible. So that's going to be x over, remember we did factorize this earlier. And so that's the form over there that we're going to look at for our sign analysis. These two x's you can actually cancel when you're doing the sign analysis. You don't have to. You can keep those x's there if you want to. Not a problem. But they're going to cancel out anyway, so I'm just going to leave them out. Okay, so I'm going to choose something for this side over here. I'll start there. So I'm going to choose x as minus 2. Now, I'm not physically going to go put x as minus 2. You can if you want to, but I just want to know if the answer is negative or positive. I don't care what it is. I just need to know if it's negative or positive. So the way that I do that is I just go fill in, I pretend that if x was a negative 2, what would this bracket be? Would it be negative or positive? It would be negative. Doesn't matter what negative it is. And then if I put negative 2 into this bracket, it would also be a negative. And so a negative times a negative at the bottom is going to end up being a positive. And so this whole expression would actually just be positive. So because it's positive, it means the graph is going to be going upwards like that. Why do I say that? Well, it means that the y value is somewhere positive. So it could be there, or it might be there, or it might be here. We don't know exactly. But because it's anywhere above this horizontal asymptote, the graph is definitely going to be going up. Because it can't cross this horizontal asymptote, or it typically doesn't. So let's say it's here, for example. Then what the graph does is it goes along the horizontal asymptote and then up along the vertical asymptote, like that. Okay? It's definitely not going to be going downwards over here, because then the y value is negative. Okay, so what we now need to do is see what happens along this side of the vertical asymptote. So I'm going to use x is as negative a half. I'm not going to choose 0 because that's a whole. Well, I guess we could, but yeah, I'm just going to choose negative a half. I'm going to choose x as negative a half, so x equals to negative half. So if you had to put negative a half into this bracket, it would be negative, and if you had to put negative a half into this bracket, it would actually be positive, because negative a half plus 1 is half, so it's a positive number. So if you had to go and analyze all of this, at the bottom, you're going to end up with a negative, because a negative multiplied by a positive is a negative, and so all of this is actually just going to end up becoming a negative. And as I say, if you want to go and plug the negative a half in, you can. You can go actually plug it in and see what you get on your calculator, but this is just a little faster. Okay, so we're getting a negative. So what that means is that the graph is going downwards for this one. Okay, now we need to see what's happening on this side. So I'm going to use x as 2. So let's use x as 2. So if x is 2, then this bracket would be a negative. This bracket would be a positive. So if you had to go do the whole analysis over here, you would end up getting 1 over 2 times a negative number. And then you're just going to end up getting 1 over a negative number. And this whole thing is just negative. So it's going to go down like that. Now we just need to see what's happening on this side over here. So for that side, we can let x equal to 4. So if x is equal to 4, then, and you could choose x equals 5. You don't have to choose the numbers that I'm doing. But if x is 4, this would be a positive, and this would also be a positive. So this whole expression would just be a positive. So that means the graph is going up on that side. Okay, so now it's just a matter of sort of completing and filling it in. So here's a horizontal, so it's probably not going to cross over there. It's just going to go around through the hole and then down like that. And then for this one, it's probably going to go down like this and then see the horizontal asymptote, and then it's just going to turn and go along the horizontal asymptote. Okay, so that is what that graph would look like over there.